To expand our understanding of simple interest investments and loans, we will now consider simple interest future value. Here's the formula. The amount in an account for a simple interest investment, now just think basic savings account, right, is given by A equals P plus I. So the amount in our savings account is going to be equal to the principal P, that's how much we initially deposit, plus the interest that we earn. Now, recall from the previous section that simple interest is calculated as principal times rate times time. So I can replace this interest I with its formula PRT, and that's what we see here on this line. So the amount in the account is equal to the initial principal that we deposit plus the interest calculated as PRT. Now notice those two terms have a P in common. So if you remember from college algebra, you can factor out that P to the left and rewrite the formula as A equals P times 1 plus RT. Note, A is the amount in the account after the term of the loan or investment is complete. So this is what your investment has grown to, right? You start out with an investment of P principal dollars, and it grows to this amount A. Since it grows to this amount A, this amount is also known as the future value. Now, sometimes the principal is called the present value. Okay, if the principal, the amount that I begin my savings account with is P, that is my present value in the account. Then I wait over the term of the investment and I come back at the end of the term. The amount in the account will have grown and we call that the future value. So let's see how this formula works in an example. What is the future value of a $1,000 loan at 3.2% interest for 2 years? Now keep in mind, this is from the perspective of a loan. Loans and investments are governed by the same equations. The perspective is just a little bit different. So this is a loan and we are borrowing $1,000. So the principal is, in this case, the amount that we are borrowing. The rate of interest is 3.2% and the term of the loan, or the time here, is 2 years. We're looking for the future value, which we call A in the formula. So the formula we're using is A equals P times 1 plus RT. So our future value is going to be our principal, that's the $1,000 that we borrowed, times 1 plus the rate of interest. We need to convert that to a decimal, so 0.032 times 2 years. Let's go ahead and type that into our calculator, and you can type it all in one step. So we have $1,000. We're going to open parentheses, that's up there above the 8, times 1 plus 0.032 times 2, close parentheses. So the future value of the loan is $1,064. Okay, what that means, we've borrowed $1,000. So after 2 years, we're going to owe not only the $1,000 that we initially borrowed, but an additional $64 for interest. So our loan will have grown to a $1,064 debt that we owe. Now, in some situations, we are going to run into a little bit of algebra that we need to be prepared to handle. So let's give it a try on example 4. What is the interest rate? So my interest rate is unknown on a $12,000 loan with a future value of $14,052 in 3 years. So the $12,000 loan, that's how much we've borrowed. That's our principal. Now this loan is going to grow to $14,052. That's our future value, or we called it A, the amount in the formula. That's the initial $12,000 that we borrowed plus the interest that we owe. And the term of the loan, or the time here, is 3 years. We want to know what interest rate drove that future value. So let's identify our formula. A is equal to P times 1 plus RT. Our principal value, let's start with A. A is $14,052. And our present value, or principal, is $12,000. We don't know R, that's what we're trying to find, so I'm going to leave that as an R, times 3. Now, it's customary to write your coefficient, or the number, on the left side of the variable, so I'm going to switch that around and call it 3R, just to make it easier to read. Now, our goal is to solve this equation for R. R is right here, and notice it is guarded by a set of parentheses. R is in jail, it's got some guards, we want to bust it out of jail, right? This guard out here, 12,000, we're going to get rid of him first. I'm going to divide both sides by 12,000 so that the guard is gone. Now follow me closely on this. I'm going to save all of my calculations to the very end of the problem so I can type it into my calculator in one step. That way I'm not going to accrue any rounding error. If I round on the next 3 steps, I'm going to get a little bit of rounding error and I'm not going to get the right answer. Okay, so I'm going to leave this number as is. 14,052 divided by 12,000. This is equal to 1 plus 3R. Now, I'm trying to solve for R, so I need to undo all of the operations applied to R. The next step is to get rid of this 1. 1 is being added to 3R, so I'm going to subtract 1 from both sides. That's going to look like 14,052 divided by 12,000 minus 1. Okay, so I've subtracted 1 from the left. On the right, it canceled, and that leaves behind a 3R. Now, hang in there. We've got one more step to do, and that is to undo this multiplication by dividing both sides by 3. So the result we need to calculate is 14,052 divided by 12,000 minus 1 all over 3, and that's going to give us our rate of interest. Now, I mentioned this in a previous video, but notice we have a fraction that contains an operation in the numerator. In order for our calculator to correctly evaluate that, we have to get that operation in a set of parentheses. It's not written there naturally. We have to know to put that set of parentheses in there. Okay, here we go. I'm going to type it directly into my calculator in one step. 14,052 divided by 12,000 minus 1, close parentheses. Now, to enter the fraction bar, a fraction bar is simply the division operation, so I'm going to type it in as divided by 3. And we're going to end up with 0.057. That's the decimal form of the rate, but usually it's quoted as a percent. So let's go ahead and convert that back to a percent by moving the decimal 2 places to the right. So this particular loan has a rate of 5.7%. So my question to you is, what's worse, the truth tables or facing all of this algebra? You'll probably have your preference. Some people love the logic, some love to crunch the numbers, and you'll also probably find that you have strengths and weaknesses. But this class changes from chapter to chapter, so hope you learn something from each chapter, and don't give up. Keep sight on your goal. Whatever your degree is going to be, it will be worth it when you get there. So hang in there, keep persevering. One more example. You want to save $1,000 in 1 year. That is an excellent goal for a college student. Save $1,000 in 1 year. How much must you deposit now at 3% interest in order to achieve your goal? So, because you are a college student and you have education about simple interest, you're going to take a lump sum of money now and you're going to deposit it at the beginning of the year in a savings account that pays simple interest, and you're going to let it grow to $1,000, right? So how much should you deposit now? What is the present value? Keep in mind, this is a simple interest savings account, so we're using a simple interest future value formula. Just a heads up, we will also have a compound interest future value formula, so we'll want to distinguish between the two. Our goal, the future value that we want to attain, is $1,000. We want to know, how much should I deposit now? What's the present value or principal at 3% interest? Move it 2 places to the left. This would be 0.03, and we're only looking at 1 year, 0.03 times 1. So I'm going to simplify what's inside parentheses there as 1.03. The algebra is a piece of cake on this one. We need to get p by itself, so we're going to divide both sides by 1.03. So our solution will be $1,000 divided by 1.03. Our present value is therefore, let's round it to 2 decimal places to the nearest penny, $970.87. $970.87. So if you deposit $970.87 at the beginning of the year, by the end of the year you would have achieved your goal to have $1,000 in the account. And the rest of that money from $970 to $1,000 you earned simply by leaving your money there. Now, we've talked about this goal of saving $1,000 in 1 year. The average person, in particular, the average college student who needs to pay tuition and books and buy calculators and pay my math lab fees and pay rent and food, all of that stuff, you probably don't, now I don't want to assume anything, but the average person doesn't have that kind of cash lying around just to deposit and leave alone. The average person saves money by depositing a little bit every month throughout the year. And that's actually how you save for retirement as well. And we're going to also cover the mathematics of that. And I think that will be very beneficial to help you understand a very efficient and excellent way to save money. For now, we have an understanding of simple interest, which is the foundation for all of our other financial formulas to come.